Hi, welcome to this video for the bolt calc application. The bolt calc is a tool for the design of bolts on the shear and tension stress. The user interface, as you are seeing right now, is divided in four main windows. Here we have geometry, material, results, and calculation details. The first two windows are for the inputs. The last two windows are for the outputs. So going back to the geometry window, here the user can define some geometrical parameters. This image at the middle can provide some better understanding about each one of these parameters. So here, for example, the user can define the spacing between bolts and the distance from the edges. Following the material section, here the user can define the class of the bolt, the safety factor for its own analysis, and the strength of the plate, and of course the loads. In the results window, the user will find the safety factor for each verification. So here we can see the safety factor for the shear stress, for the bearing stress, tension stress, punching, and combined shear and tension stress. The last window, in calculation details, the user will find all the results such as the stress area of the bolt and the resistance of the bolt in tension, in shear, in bearing stress, and punching. We are going in more details for each one of these inputs and outputs in the example. We also provide some information or explanation using dialog box. So here, for example, in the tensile strength, this dialog box here shows the formulation adopted in the application. We also provide a deeper explanation about the application in our documentation page. So here in the top left corner, we can find the link from the documentation page. In this page here, we provide, in fact, a deeper explanation about the inputs and the outputs. So here we can find, for example, the formulations that were adopted in order to calculate the resistance of the bolts, such as in tension, in shear, in the combined shear and tension, in the bearing stress, and punching. We also have some information about the user interface. And we have a validation test case. We can use our validation test case as our first example. So in this case here, we have a single beam to column joint with a header plate. Okay, as you can see in the below image. We also provide the inputs. So here we have the thickness of the plate, the position of the bolt. So in this case here, we are verifying an edge bolt like this one here. And we also have the diameter of the bolt equals to 20 millimeters. Okay. We also provide the distance, such as this one, E1, P1. They are in the direction of the load, and also the distance E2 and P2, okay, that are perpendicular to the load. Our material inputs, so here we have the bolt class 8.8, our safety factor, and of course the strength of the plate. Okay. We also have the total shear and traction force in the connection, the number of bolts, and the applied shear and traction force for each bolt. Okay, so let's try to verify this example in our application. Okay, back to our application, we can begin our first example. So we can start by defining the geometry, of course. So here E1, the distance along load direction is 45 millimeters, like this one here. Okay. E2 is equal to 50 millimeters, 50. P1, the spacing between bolts along the load direction. So P1 is 70, like this one here, P1 here. And P2 is equal to 100. Okay. We are verifying an edge bolt, so this is okay. The thickness of the plate is 10 millimeters. The bolt diameter is 20 millimeters. Okay. Moving on, in the material section, we can define the class of the bolt, which is 8.8. Let's check. Yes, 8.8. The safety factor is okay, 1.25. The strength of the plate is also correct. The tension force, let's see, tension 3.3 kilonewtons, 3.3. The shear force is 33.3 kilonewtons. Okay. So in the results window, we verify that everything is okay. The safety factor for the shear stress 0.35. The safety factor for the bearing stress is also okay. For the tension, for punching, and for the combined shear and tension stress. So everything is okay here in this case. Okay, we can also try to change the load. Okay, let's see if I put here 50 and 50, we see that okay, is still okay. Let's try more. Let's say 100 and 100. Okay, all right, that's it. And see, in this case, we see that okay, some verification are not satisfied. They are indicated in red.